Nested functions are functions defined within other functions. They are useful for organizing code and encapsulating logic in a local scope. In the code snippet that you see on your screen, an outer function named outer encapsulates an inner function called inner. The inner function takes a single argument y and returns its doubled value. The outer function calls inner twice, passing the same input x to it each time, and then multiplies the two returned values together. This structure allows for compartmentalizing part of the computation, that is, doubling a value within the inner function and then using its result in a broader calculation, which is squaring the doubled value in the outer function. It demonstrates how nested functions can be used to build complex operations from simpler reusable components, with the inner function scope being limited to the outer function, thereby enhancing modularity and readability. Using regular functions in place of nested functions would complicate the code by requiring the inner operation to be globally accessible, potentially leading to namespace pollution and making it harder to understand the relationship between the doubling and squaring operations. Nested functions, by contrast, keep the doubling logic neatly encapsulated within the squaring operation, thereby clearly indicating the logical flow and dependency. In the second example, a function named perform underscore operation is designed to apply an operation to two numbers. Inside the perform underscore operation, a nested function add is defined, which takes two arguments and returns their sum. The outer function then calls add, passing it specific values and returns the result. This pattern showcases how nested functions can encapsulate specific operations like adding two numbers within a broader context, that is, performing an operation, allowing for clearer, more organized code by keeping related logic close together and limiting the scope of helper functions like add. In the scenario of performing operations with nested functions, regular functions would force you to define add function at a global level, reducing the clarity of how it is specifically tailored to the perform underscore operation context. This global approach dilutes the specificity of the operation and the encapsulation benefits, making the code less modular and potentially more error prone if the add function were mistakenly used in unintended contexts. In the third example, we have a function called greet underscore person that decides how to greet someone based on the time of day. Inside this function, there are two other functions, morning underscore greeting and evening underscore greeting. Each of these nested functions returns a greeting tailored for either the morning or the evening, respectively. When you call greet underscore person, you need to tell if it is morning by passing true or false. Based on what you pass, greet underscore person will then choose to give you back either the morning greeting function or the evening greeting function. It doesn't actually call these functions itself, it just returns the one that is appropriate for the time of the day you indicated. After you call greet underscore person function and get back the right greeting function, you can then call this returned function with a name to get a personalized greeting. If you said it was morning, you will use the morning underscore greeting to say good morning followed by the name. If you said it wasn't morning, you will use the evening underscore greeting to say good evening followed by the name. So this code is a very clever way to select and use different greeting functions based on the time of day, demonstrating how nested functions can be used to encapsulate and return specific logic. Nested functions thus provide a streamlined, intuitive way to organize related logic and only accessible by the decision-making logic it supports.